Hello, guys. Welcome back. So today we are going to talk about the digestive system. So let me share my screen. All right, so that's this one here. So digestive system is an extension from our earlier lecture talking about the uh, macro molecule. Macroorganic molecule, basically. So we learned about the metabolism. We learned about how these molecules has their own monomer and have their own polymers. So I hope you still remember those. Um, and today we are going to focus on how does our digestive system working on breaking down the polymers to become monomers so we can absorb them from our food. So that is basically an application from the uh, the uh, the earlier lecture. So just a quick review, a quick summarize what we have know about the metabolism. Metabolism is is how do we deal with this polymer and monomer. So basically, we know that polymer can be break down into monomers, like proteins to become amino acids. Carbohydrates can be become glucose, for example. And so those are the breaking down part. And this can also be putting together to become the polymers. And so metabolism involves a breaking down and putting back. So breaking down the process to break down the molecule is called catabolism, and the process to put them together is called anabolism. And so anabolism is how our body build our own body, build our cells, build our organs by using those monomers that we absorb in our body. And today we are going to talk about the catabolism. That's how our digestive system breaking down the food that we eat. So here is the metabolism. So have our story here. And so basically the larger picture is that you need to get the building bricks from the food. So food is large stuff. So you need to break it down by chewing it, by digesting it. And then you basically will absorb proteins, carbohydrates, and fat. These are large stuff. They are not going to be able to enter to your body. They are not going to be absorbed by your small intestine. They need to break it down into the monomer. And so here is the monomer. Protein's monomer is amino acids. So we have this quiz question like multiple times. What is the monomer of protein? You need to know that is amino acids. And the carbohydrates break it down into the monosaccharides. There are multiple type of monosaccharides. We talk about the glucose here. We also talk about the fructose, galactose. Those are the three major ones from our food. That's the monomer that we monosaccharides that we can absorb. And so that's that. Then we can absorb. Fattiest fats can be uh, uh, break down into fatty acids. So that's that. And then this will be able to enter to our body. Now they become the building bricks. We will use them to form the protein in the right location, the right type of protein that we will synthesize them, and then you then use them in our body. Glucose we use it to build our energy source like glycogen, for example, and then fatty acids. Will we will use them to build several things. In here, the example is the cell membrane. That is the uh, phospholipid. That is basically dissect di di uh we have two fatty acids basically. Let's put it this way: two fatty acids together. We can also store them as triglyceride, three fatty acids together, and store them in the fat tissue. So that's that. So this is basically is a catabolism process and anabolism process. This portion, breaking it down, is done by digestive system. Yeah. So we will take in food, then through our digestive system right here, taking food through our digestive system. In the end, we will have amino acids, glucose, fatty acids, and glycerol. These are the monomers. Once we have these monomers, we will have them in our small intestine. Small intestine will absorb them into our body. So that's how we do the digestion. So overall, we need to know our carbohydrate digestion, our lipid digestion, and the protein digestion. Basically, we will have this, the main organ to work on each of these uh, through our digestive system. In the beginning, it will be in our oral cavity, our mouth. The carbohydrates is a primary one get digest here. Then things going into the stomach. Stomach is very acidic. It will have the function, many functions. For the digestion portion, it, this acidic environment can denaturalize the protein. And so this is the beginning of protein digestion. And once it enter into the small intestine right here, the gallbladder will infuse the bile acid. Bile acid work on fat. So this one combined with the enzyme from the pancreas, it will help our body to digest fat. So both fat and other nutrition, including the protein and carbohydrates, will further be digested in our small intestine. And then very quickly, this in the small intestine will be absorbed because they are all become the monomers. They will be absorbed into our body. And then the remaining portion, we will poop them out. So they will go through the large intestine. And then those remaining portion that we are not going to absorb, we will poop them out. It's called feces. So that's that. So this one, when we go through this one, we know that all these different organs are essential for our digestive system. So we will go from the beginning all the way to the end. Yeah. So you need to be able to label all this. Label all this. You need to know, because this is probably the most simplest version of the digestive tract or digestive system. The tongues, the mouth, teeth, salivary glands. This one release saliva. Then here is the pharynx. We um, we also mentioned about this one in our respiratory system. Esophagus, this is a major tube for the food. Stomach, the tube continue to the small intestine right here, small intestine, and then going to large intestine. And in the small intestine, liver release bile acid stored in the gallbladder, inject into the small intestine. Pancreas also release enzyme to the small intestine. Then going to the large intestine, then rectum, anal. Here in the large intestine, the beginning of that, we have the appendix. So that's everything here. Yeah, you need to be able to label it. So let's start by the first one, the entrance of the food. They are going to our mouth. So mouth play an important role to break down our food by using force. So food is big, as you can see here. They are big. So they need to be cut. And we can cut it by your knife. We will cut it. But it's small enough to our mouth. But our teeth will also cut it further to make it even smaller. So we call this one a mechanical digestion. Basically, just cut it smaller. It's not to the molecule level, but it's smaller than its original size, right? So that's that. So that's mouth. So that's the major function is to cut it. So you need to take good care of your teeth. They are important for your digestion and also absorption. If you don't digest them well, you cannot absorb it. So you will be lack of nutrition if you don't have healthy teeth. Yeah. And in addition to the mechanical digestion, saliva also release enzyme. This one is particularly powerful to digest the carbohydrates. The original form of carbohydrates are polysaccharides, so they are polymers, and so this enzyme can make it smaller, break it apart. So that's that. This is a simple anatomy of the mouth. So you have lips, uh, the upper lip, lower lip. You have teeth, uh, upper portion and the lower portion. In the upper portion, you have the palate. The beginning here is the hard palate. Later here is soft palate. Continue soft palate, you have the uvula. This uvula is important to prevent when you eat stuff, prevent the thing going into your nasal cavity. I think I have a picture. Oh no, I don't have a picture right here. So here is the nasal cavity. When you swallow, you will use your uvula to block the way from your mouth into your nose. Yeah, so if you're not paying attention, things can go into your nose. Yeah, so that's that. That's uvula. Uvula is continues from the soft palate. So here it says soft palate. That's that. We also have tonsil. This is part of our immune system. This basically is a larger size of lymph node. So that's that. You release a lot of mucus here, and the mucus plus the epithelium cells is called mucosa. Yeah, so that's that. Here is the we learned about this alveolar process from the bone and mandible, basically mandible, and the skin and the soft tissue covering it. This soft tissue is called gingiva or gum. Yeah, so that's all right. So the major function of the mouth is to do the mechanical digestion, and the enzyme can break down the carbohydrate. So this is the same slides I showed in our earlier lecture about the molecule. So polysaccharides is the original like large form of our food. Then we need to it's a polymer, so we need to break it apart. Then it will become polymer, gradually become smaller piece. Then the polysaccharides can become the disaccharides, then become the monosaccharides. So monosaccharides is just single monomer. single monomer. So we can have glucose, galactose, fructose. The disaccharide is two of them. So we have sucrose, maltose, lactose. And so that's that. We need to, the purpose of digestive system is to break this one from starch all the way down into glucose, galactose, and fructose. Then our body can absorb it. So that's mouth. Then after our digestion, we will swallowing it. This is a swallowing process. And so it shows 2, 3, 4. Basically, this one showing you the reflection. So basically, when you push your food, when they touch the soft palate, it will trigger a swallowing reflection. And then the reflection include your soft palate plus uvula to block the uh, entering into the nasal cavity. So this portion is blocked. And then food will continue on to the esophagus. You can see that esophagus is usually closed. So here is the upper esophageal sphincter, short for US. This is usually closed. Air coming this way, this is usually closed. But food will go through it. Another thing we also need to know here we have something called epiglottis. Epiglottis is the the cartilage. Here you can see this white portion is cartilage that can uh, block the entrance into the larynx, and so food will not go into the airway, and the food will continue entering the esophagus, and then this upper esophageal sphincter will then close again. Then food will get pushed all the way down to into our stomach. So that's swallowing. So here is the esophagus. So you can see that this esophagus has smooth muscle. It has this circular muscle, and you have longitudinal muscle. Then this muscle will, when you stretch it, this muscle will respond by contrasting it, and then they will continually pushing it all the way down into the stomach. Yeah. So esophagus connect the pharynx. So here is the pharynx. This whole portion is the pharynx. So we have the nasal pharynx, oral pharynx, and the laryngeal pharynx right here. So this is pharynx, and it will connect the pharynx to the or throat to the stomach. So that's the esophagus. Now, when it enter into the stomach, it will stay in stomach for up to 4 hours, uh, depending on the type of the food. If it's liquid, it will going down very quickly. If it's very solid, it will stay here for around like 4 hours. So here is just some naming or labeling of the stomach. Stomach has two ends. The upper end connect with the esophagus, and the lower end connect with the small intestine. Duodenum is the first segment of the small intestine, and so here it shows duodenum, but it basically is a small intestine. Uh, Stomach has two ends. These two ends basically has a certain level of sphincter. So sphincter is a closure, a tightly closed smooth muscle. So The pyloric sphincter is especially closed pretty tightly. Uh, cardia, this region doesn't close that tightly. It closes, but it's not as tight as the uh, pyloric sphincter. So when food come in, they will stay here. They will stay actually up more here because you need to know that stomach can contrast. It has a smooth muscle. It will push it. It will stay it more like in the fundus area. This the core body is fundus. This portion is pylorus. This pyloric sphincter. So that's that. This is just additional name. You just need to know that this sphincter is the pyloric sphincter. I think that's good enough. This portion is called the lesser curvature. This portion called the greater curvature. Yeah. So so that's that. So that's the stomach. The function of the stomach is to mix the food with the uh, gastric juice. So the stomach release many different kind of fluid. It release acidic fluid. It make this environment very acidic. It will also release enzymes to break down the protein. And so this acidic environment will denaturize protein. The enzyme will further break down the protein. We will talk more about that. In addition to that, stomach muscle will also mixing everything all together. So it will do the mixing, and while it's mixing, everything will stay in the stomach for a couple hours. And here is the pyloric valve or pyloric sphincter. It will control how much of this thing can get released into the small intestine. This is called chyme. You don't need to know it yet, but it's a mixing stuff, mixing food. Let's put it this way. Then it will get slowly and gradually released into small intestine. You don't want everything to come in or at the same time because you don't want to uh, cause too much of the work in the small intestine. And so you slightly release a bit into the small intestine, and then small intestine can do the final process before they absorb the food. So this process is called stomach emptying. They will empty the stomach gradually into the small intestine. So the function of the stomach basically including mixing, including the storage, and also more importantly is their environment have this acidic environment and also enzyme to break down protein. So that's the key. This is the primary organ, one of the primary organ to break down proteins. Mouth, before that, is to break down carbohydrates. Stomach, the next stop here, stomach is to break down protein. Yeah, so that's the key. So protein is folded. It need to be denaturized, and a powerful way to denaturalize it before we can cut it, right? You need to untangle it, and then it expose its a chemical bond. Then it's easier for us to digest it. And so the a very powerful way to denaturalize a protein is an acidic environment. So the stomach juice is very acidic, and so it can unfold all this protein, allow the enzyme to break it further apart. And its enzyme has is right here. So stomach, basically it will first denaturize it, and then this enzyme will break it apart. It will expose all this chemical bond. Then this chemical bond can be exposed, so enzyme can work on it to break them apart. So that's that. Protein digestion start at the stomach, denaturalize it. That is a very important step, and enzyme to break apart. But the protein digestion doesn't stop here. Further, more work still need to be done in the small intestine. After they released all this food into the small intestine still need to continue work on it to further break them apart to become the monomer, to become the amino acids. So that is the stomach. So let's take a break and we will continue. So that is, we've been talking about from our mouth all the way into the stomach. And basically at this point, you won't see the size, the shape of the food anymore. Everything is very smooshed all together. And let's take a break, and we will continue our lecture to talk about the remaining journey of our food, uh, and during our within our digestive system. All right.